In this video, we're going to talk about the closure property of rational numbers. And we already know that rational numbers are numbers of the form p by q, where q is not equal to 0 and p and q are integers. Now, when you think of the word closure, does that ring any bell? Isn't it very similar to the word closed? Now, if you think of it as a closed property rather than a closure property, it kind of makes it a bit easier to understand. Now, here we have a box. Here's another kind of box. Now, this is a box which we call as a closed box, right? And this we would say it's an open box. A closed box, we say it's closed because it kind of tends to keep things inside within itself, right? It doesn't let anything go out or let anything come in. Whereas an open box allows things to go out of it or come into it, sort of freely. Now, here's another box for you. Now, this is a box of rational numbers. Now, what I mean by that is any rational number that you could think of would be inside this box. It could be 3, it could be 1 over 2, it could be 164, 22 by 7, which is a rational number, 98 over 1, or any other number that you could think of, which is a form p by q, and q is not equal to 0, and p and q are integers, will be inside this box. That's this box of rational numbers. Now, the more interesting part here is if we perform any operation, any mathematical operation, right, like addition, subtraction, multiplication, or division, we still tend to get a rational number. Now, for example, if I add these numbers, or if I subtract a number, or if I multiply these numbers, or if I divide these numbers, we will always tend to end up with another rational number. Almost always, right? We'll see about that very soon. So the idea here is these operations are closed for rational numbers. When you perform operations on a rational number, you always get another rational number. That's what we mean by the idea of being closed. We tend to stay within this box. Now, the idea is very similar to having a couple of ice cream cones. Like let's say you have a couple of blueberry cones. When you combine them, you tend to end up with a couple of blueberry cones, right? You would end up with 2 blueberry cones. You would suddenly not end up with 2 vanilla cones, right? The flavor of the cones tends to be the same. Similarly, the flavor of the number tends to be the same when you combine numbers. Let's see some examples. Let's say I add 3 by 4 with 1 by 2. Both are rational numbers. We end up with 3 by 4 plus 2 by 4 because I take LCM as 4 and 1 to 2 is 2, and we end up with a 5 over 4, right? 3 plus 2 is 5. So this is also a rational number, correct? We added 2 rational numbers and we ended up with another rational numbers. So addition is a closed operation for rational numbers. If you add 2 rational numbers, you will always end up with another rational number. Now the same goes for subtraction as well. Let's say you take 5 by 3 and subtract it with 8 by 3, you'll end up with what? Minus 3 over 3, which is minus 1, which is also a rational number. So subtraction is also a closed operation for rational numbers. Subtracting any 2 rational numbers will always give you another rational number. Now the same goes multiplication as well. Let's say you multiply 5 by 8 with minus 2 over 3. We end up with a 5 2 is 10, 8 3 is 24. So minus 10 by 24, and so further simplifying that, you end up with minus 5 by 12, which is also obviously which is also clearly a rational number. So multiplication is also a closed operation on rational numbers. Now the only interesting part here is division. So if you divide 5 with 2, we tend to have another rational number, so that's fine, right? But if you divide 5 with our friendly neighborhood 0, then you would not have the closure. The number tends to be undefined and it's outside the box of rational numbers. This is not a rational number because you cannot be 0, correct? That's our definition. So this is the only place where the property of closure breaks. And division is not closed for this reason. Division is not closed on rational numbers, which means we can't say dividing any 2 rational numbers will give you another rational number. It doesn't. So that's why addition, subtraction, and multiplication are closed for rational numbers, while division is not closed for rational numbers. And that's about the closure property of rational numbers. See you in the next video.